Question 2.2. Yes, this is a little bit overwhelming. Okay, we've got a quadratic sequence. At least they told us what type of sequence it is. And we've got a general term with the following properties. Term 11 has a value of 190. And Tn minus Tn minus 1 equals 4n minus 3. So long as n is equal to 2 or bigger. And they want us to determine the first term of the quadratic sequence. Okay, so this over here is a very complicated way of giving you the rule for your first difference. So any given quadratic sequence, I kind of set this placeholder up. So you want space for your quadratic pattern at the top. You want space for the arithmetic pattern that forms the first difference in the second row. And the last row should be comprised of the same numbers because it's constant. It's a constant second difference. Unfortunately, this is not on your formula sheet, so all of this you'll have to know off by heart. Okay, so in a very complicated way, they gave me the pattern rule for the arithmetic pattern. When they say Tn minus 1, it's basically like saying this one minus this one gives me that one. But they've given you the rule that applies to all of them. So we're going to use that rule to our advantage. We're going to use that rule to get these three numbers. Okay, so this is giving us instructions that you must start at 2 with this rule. So I'm going to replace these three n's with 2. Okay, and then I'm going to simplify that a little bit. 2 minus 1 is just 1. 4 times 2 is 8. 8 minus 3 will give me 5. And that 5 is going to be my first number over here. Okay, now I'm going to repeat that procedure with a 3 instead of a 2 to get the next one. You just go up by a whole number, so 2, 3, 4. We're going to get those guys now. Okay, 4 times 3 is 12. 12 minus 3 will give me 9. So my next number over there is a 9. And just for comfortability's sake, let's get this out quickly. And then 4 times 4 is 16. 16 minus 3 gives me 13. Okay, now that we've extracted those three, we can see we're adding 4 each time. So this number over here is 4. Okay, and now this will enable us to solve for A as well as B to put inside of our quadratic formula or quadratic equation for quadratic sequences. So over here, I just divide both sides by 2 and A will be 2. And then 3A plus B will give me 5. And I put this A into this guy. So I put the 2 into A there and I'll solve for B. 3 times 2 is 6. If I move that 6 over, it becomes minus 6. And 5 minus 6 will give me negative 1. And then I just fill that into the placeholders of A and B. This 1 doesn't even have to be here, so we can get rid of it. And now we're running into a bit of a problem. We don't have the C value, and we have no way of getting it from this. So we're going to use this to get it. Term 11 has a value of 190. So we're going to pop those in here. The 190 will go in here, and the 11 goes in n's place. And then once we pop those in, we just need to solve for C. So I'm literally going to type this into my calculator. I don't want to do mental maths and take a chance. So 2 times 11 squared minus 11 will give me 231. So let's make that replacement. And then we take the 231 over and it becomes a negative. So let's calculate that quickly with our calculator. Gives me minus 41. Once that's out the way, I just chuck it back into my Tn formula that I originally had. You just replace C with what it actually is, minus 41. And now they want the first term of the quadratic sequence, so I just replace all the n's with a 1. And after I've done that, that goes straight in the calculator, don't take chances. And there's my first term, minus 40. And your 5 marks are achieved from your first differences. So you don't actually have to show all this working out. You can just get them straight by putting them into your calculator. Second mark comes from the correct A value. Third mark, correct B value. Fourth mark, the correct C value. And the last mark comes from the correct final answer.